In this video, we are going to discuss about limits at infinity. We are referencing Calculus with Analytic Geometry by Thurman Peterson, created by Sir R. Squared. Ang pangunahing layunin ng bidyong ito ay maturuan ang mga mag-aaral kung paano mag-evaluate ng limits as x approaches infinity. At ang kahihinatnan ay matutunan ng mga mag-aaral ang pagsosolve or pag-evaluate ng limits at infinity. Disclaimer: ang bidyong ito ay ginawa ng may akda upang magamit sa pagtuturo ng matematika at maging sandigan ng mag-aaral sa kanilang pag-aaral ng calculus. Ang bidyong ito ay maaaring mai-download ng walang bayad or for free sa www.youtube.com. Ano man pong maling paggamit sa bidyong ito maliban sa nasa saad sa taas ay hindi po responsibilidad ng may akda. This video is not regulated by the institution. Any flaws in this video is at author's imperfection. Limits at infinity. Number 1. The limit of a constant as x approaches infinity is the constant itself. Number 2. The limit of 1 over x as x approaches positive infinity is equal to 0. And the limit of 1 over x as x approaches negative infinity is equal to 0. Number 3. The limit of x as x approaches positive infinity is equal to positive infinity. And the limit of x as x approaches negative infinity is equal to negative infinity. Number 4. The limit of x squared as x approaches positive infinity is equal to positive infinity. And the limit of x squared as x approaches negative infinity is equal to positive infinity. This is also good for all exponents that are even. Number 5. The limit of negative x squared as x approaches positive infinity is equal to negative infinity. The limit of negative x squared as x approaches negative infinity is equal to negative infinity. Number 6. The limit of x raised to an odd exponent as x approaches positive infinity is equal to positive infinity. And the limit of x raised to an odd exponent as x approaches negative infinity is equal to negative infinity. Number 7. The limit of 1 over x squared as x approaches infinity is equal to 0. And the limit of 1 over x squared as x approaches negative infinity is equal to 0. Number 8. The limit of a constant times x as x approaches positive infinity is equal to positive infinity. And the limit of a constant times x as x approaches negative infinity is equal to negative infinity. Limits at infinity. If you have a rational function, divide each term by the highest power that appears in the denominator. In this example, we will illustrate what does this mean. Example number 1. We are asked to evaluate the limit of 3x cubed minus 2x plus 4 all over 2 minus 3x squared minus 2x cubed as x approaches infinity. We are going to solve this following this note. Ang sabi po sa atin, divide each term by the highest power that appears in the denominator. The highest power that appears in the denominator is x cubed. So we are going to divide everything by x cubed. Kuha po tayo ng blue na ballpen to distinguish. 3x cubed over x cubed minus 2x over x cubed plus 4 over x cubed all over 2 over x cubed minus 3x squared over x cubed minus 2x cubed over x cubed. This one will be 3. And this one will be 2 over x squared. This one will be plus 4 over x cubed. All over, this one is 2 over x cubed minus 3 over x and then minus 2. Remember, the limit of 1 over x as x approaches infinity is equal to 0. Okay. So, ganyan po ang ating gagawin at i-apply, ano? Lahat po ng may x sa denominator, atin na pong i-approach sa 0. This will be 0, this will be 0. Therefore, the answer is 3 over negative 2 or negative 3 over 2. Okay. Example number 2. We are asked to evaluate the limit of 3x squared minus 2 all over x plus 5 as x approaches positive infinity. Following the rule, we have to divide all terms by the highest power of the denominator, which is x. So we have 3x squared over x minus 2 over x all over x plus 5 over x. Now, lahat ng may x sa baba will approach 0. This will be approaching 0 and x over x will be 1. And this one will have 3x because x will cancel out. So what we'll have is 3x over 1, and if we're going to plug in infinity multiplied by 3x, we will have positive infinity. Number 3. We are asked to evaluate the limit of 4x squared plus x plus 1 all over 2x cubed minus 5 as x approaches positive infinity. Following the rule again, we have to divide all the terms by the highest power that appear in the denominator. We have 4x squared all over x cubed plus x over x cubed plus 1 over x cubed over 2 x cubed over x cubed minus 5 over x cubed. This one will be 4 over x and this one will be equal to 2. Therefore, lahat po ng merong x sa ilalim will approach 0 and this will be 0. We will have 0 over 2 that is equal to 0. Example number 4. the limit of 4x as x approaches infinity is equal to positive infinity. More so, the limit of 4x as x approaches negative infinity is equal to negative infinity. Just like, isipin po natin yung 4 ay i-multiply natin sa napakalaking number, let's say 1 million, it will be 4 million. Kung yung 4 ay i-multiply mo sa walang hanggan, edi walang hanggan ang sagot. So, kung sa negative na infinity mo naman i-multiply, edi negative infinity siya mag-approach. Number 5, the limit of x squared plus 2x plus 5 as x approaches infinity is equal to positive infinity. Ang technique po dito ay kalimutan na po natin yung mga less significant na terms. Katulad nito, this is less significant than this term. Kasi kapag ka ito, pinlog in mo halimbawa 1,000 squared, that will be 1 million. Ngayon, kung 1,000 ang i-plug in mo dito sa 2, that will be 2,000. That is nothing compared to this x squared. Therefore, yun lang po ang i-concentrate natin. Now, the limit of x squared as x approaches infinity will be positive infinity. So, ganun din po dito. The limit of x squared, mawawala na po ito. These are less significant than x squared as x approaches negative infinity will be positive infinity. Kasi yun daw negative infinity, kapag in-squared mo, that will be positive infinity. Number 6, the limit of x cubed as x approaches positive infinity is equal to positive infinity. So, yung walang hanggan, i-cube mo pa, edi walang hanggan na talaga yun, ano? More so, the limit of x cubed as x approaches negative infinity will be negative infinity kasi nga po, it will follow the rule of power, ano? If you raise a negative base to an odd power, you will have a negative result. So, parehas lang din po, ano? You will have negative infinity. Now, number 7, the limit of a constant 8 as x approaches infinity is equal to 8. Wala naman po kasi tayo mapagpa-plug inan noong x. Wala pong x siya dyan, kaya wala tayong mapagpa-plug inan ng infinity that is equal to the constant itself. We have some shortcuts in rational limits at infinity. If we have a rational function that is equal to n over d, wherein n is the numerator and d is the denominator, all we have to do is just observe the degree of the numerator and the denominator. Ito raw po yung key. If n is greater than d, then we will have infinity. If n is equal to d, then we will look for the leading coefficients. At yun po ang magiging value ng ating limits. If d is greater than n, then we will have 0. Let us take a look at these examples. The limit of 3x squared minus 2x all over x plus 5 as x approaches infinity, if we try to observe, the degree of the numerator is greater than the degree of the denominator. Therefore, we will just focus on this one. We'll focus on this one, and what we'll have is 3x squared over x. We will be having 3x. And we know that the constant times x as x approaches infinity will be infinity. If we are asked to find the limit of 3x squared over x as x approaches negative infinity, it will yield to negative infinity. Now, in this second example, the limit of 2x squared minus 5x all over 8x squared plus 3x as x approaches positive infinity. If we try to notice, the degree of the numerator and the degree of the denominator is equal. That is x squared. In this case, ang titingnan lang daw po natin ay yung kanyang mga leading coefficient, which is 2 and 8. So we have 2 over 8, which is 1/4. So yun daw po ang magiging sagot natin. If the degree of the denominator is greater than n, for example, the limit of 4x squared plus x plus 1 over 2x cubed minus 5 as x approaches infinity, if we try to notice, the degree of the denominator is greater than the degree of the numerator. In that case, what we will have here is 4 over 2. 4x squared over 2x cubed. And what we'll have is 2 over x. Yan lang po ang matitira. It is somewhat like 1 over infinity. Yun daw constant, i-divide mo sa infinity, that will approach to 0. So yun po yung ating paliwanag sa shortcut na itinuturo sa atin ng book sa rational function. We have a trigonometric function example in the form of sin x over x as x approaches infinity. We have a property that goes something like this. The limit of sin x over x as x approaches positive or negative infinity is equal to 0. We are going to use this property in these following problems. Number 1, we are asked to evaluate the limit of sin 3x over x as x approaches infinity. Kung atin pong mapapansin, this one does not fall on the property. Kulang po tayo ng 3 sa denominator. So ang atin pong gagawin, we are going to multiply the denominator by 3. At pag ginawa po natin yon, kailangan din natin i-multiply yung numerator by 3. In that way, we are not changing the value of the original function. Therefore, if this already falls on the property, this becomes 0. And 0 multiplied by 3 is equal to 0. Number 2, we are asked to evaluate the limit of sin 3x over 6x as x approaches infinity. So, what we're going to do here is to factor the denominator. Sa ganung paraan, makakaroon tayo ng sin 3x over 3x kung saan itong sin 3x over 3x falls under the property which is equal to 0. And then we're going to multiply that by 1/2 and that will be equal to 0. And then in the last example, we are asked to evaluate the limit of sin x squared over x as x approaches infinity. Kung mapapansin po natin, kulang po tayo ng factor na x sa denominator, so we're going to multiply the denominator by x. And we also going to multiply the numerator by x, kung kaya't imumultiply natin siya sa x over x. By doing so, we will end up with sin x squared over x squared. At ito daw po will fall under the property. So this one will be 0 and may matitirang x. If we try to plug in the value of the limit, which is infinity, to this x, 0 times infinity, or a large number, will also give us 0. Any number multiplied by 0 is 0 gaano man pong kalaki yan. So we are having 0. We have an example on exponential. Letter A, if we are asked to evaluate the limit of e to the negative 2x as x approaches infinity, we can use our knowledge in algebra to rewrite this. We can rewrite this as the limit of 1 over e to the 2x as x approaches infinity. Now, if we try to plug in infinity, and you can imagine, so this can be equal to e to the 2 times somewhat infinity. This will be a very large number, and 1 over a very large number is somewhat 1 over infinity, and that is equal to 0. Now we have the second example. If we are asked to find the limit of e to the 2x as x approaches negative infinity, we can think of it as we plug in e to the 2 times negative infinity. Now, it is just the same as e to the negative infinity. And we can write this e to the negative infinity as 1 over e to the infinity. And if we divide 1 by a very large number, or 1 over infinity, the answer is equal to 0. So that is how you evaluate the exponential function. At this point, we're going to terminate our discussion at papasalamatan natin ang ating Panginoon Diyos na makapangyarihan sa lahat, na nagbibigay sa atin ng buhay at lakas upang matutunan ang lahat ng bagay nito. Sa wakas ng lahat ng bagay, ang lahat ng parangal at papuri ay sa Diyos Amang makapangyarihan sa lahat, na nag-ahari noon, ngayon at magpakailanman, magpasawalang hanggan. Amen. To God be the glory.